Hello, grade 7, and welcome to our fourth math session. Before we start, let's make brainstorm about what you have learned in the previous sessions. Remark: we said that any number to the power 0 equal to 1, and 1 to any power is equal to 1. Examples: 7 to the power 0 is equal to 1. 1000 to the power 0 is equal to 1. 1 to the power 4 is equal to 1 times 1 times 1 times 1, which will stay 1. 1 to the power 100 will be also 1. For the powers of 10, we said that powers of 10 are all powers whose base is 10. The exponent indicates the number of zeros. So if we have 10 cubed, directly we can write 1000, 3 zeros. 10 to the power 5, we can directly write 1 and 5 zeros. Okay, let's review the properties or the rules. Rule number 1, we said if I have two powers which are multiplied having same base, we keep the base and add the exponents. Example: 5 to the power 4 times 5 cubed, keep the base which is 5 and add the exponent to get 5 to the power 7. If I have two powers having same exponent, we can distribute the exponent. Example: 3 times 4 to the power 5, so the exponent will go to the first power and to the second one. Similarly, if I have a quotient means division, two numbers having same exponent, the exponent will go to the numerator and to the denominator. 3 over 5 to the power 4 will be 3 to the power 4 over 5 to the power 4. The fourth rule: if I have a power having more than an exponent and having an parenthesis, we said parenthesis indicates multiplication, so we multiply the exponents. am to the power n will be am times n. Example: 17 to the power 5 of exponent 3 will be 17 5 times 3, 17 to the power 15. The last one: if I have a quotient of two powers having same base, we subtract the exponents. 8 to the power 5 over 8 to the power 3, it means 8. 5 minus 3, which will be 8 to the power 2. Let's make an application. The first one, we have same base, so we add the exponents. 5 in the middle, it doesn't have any exponent, so we put exponent 1. 2 plus 1 plus 5, which will be 5 to the power 8. 5 times d, or any number having same exponent, the exponent will be what? I can distribute the exponent, so it will be 5 to the power 4 times d to the power 4. The last one, similarly, but I have here division or quotient, so 12 will go to the numerator and denominator, which will be 5 to the power 12 over b to the power 12. Okay, another one. The first one, I have parentheses. Keep it in your mind. Parentheses indicates multiplication. So we multiply the exponents. 5 times 2, it will be 4 to the power 10. Excellent. Okay, the next one. We have same base, but look at the last one. 4 to the power 3 parentheses 2, we have to multiply it, so we will get 4 to the power 6 plus 0 plus 3 to get 4 to the power 9. 0.4 squared, it means 0.4 times 0.4, which will be 0.16. The last one, we have division or quotient. Quotient indicates subtraction. But first, let me get a good numerator and a good denominator. The first one, 4 to parenthesis 5, which will be 4 to the power 10, and in the denominator I will get 4 to the power 10. 4 to the power 10 over 4 to the power 10, I will get 1. Okay, before we start correcting the homework, let's recall the order of operation, which are PEMDAS. We said that if I have a mathematical expression and it contains more than one operation, we have to use the PEMDAS, which is P indicates parentheses. We start with parentheses, then E, the exponent, M and D, which are the same, multiplication and division from left to right, A and S, which are addition and subtraction from left to right. Okay, let's start correcting the homework. Exercise 5, page 18. If you notice that in exercise number 5, we have many operations: multiplication, powers, parentheses, addition, and probably subtraction. Okay, we will start with the first one. We have multiplication and exponent. According to PEMDAS, or please excuse my dear Aunt Sally, we have to start with the powers. Okay, so we keep 5 times and we solve 4 squared, which is 4 times 4 to give me 16. So 5 times 16, which will be 80. Okay, the second one, we have parentheses, multiplication and exponent. We have to start with the parentheses, solving inside the parentheses 5 times 4, which will be 20, and keep the exponent squared. 20 squared, it's 20 times 20, which will be 400. The next one, similarly, 3 times 4, which will be 12 squared, 12 times 12, which will be 144. The next one, even the exponent is stronger than the addition, but we have parentheses. Parentheses, we have to solve it first. Inside the parentheses, we have 8 plus 5. Pay attention here. We can't write 8 squared plus 5 squared because here we have addition. The rule is over multiplication only. We can put the exponent on the numbers only over multiplication or division. So here we have to solve using order of operation, starting with the parentheses to get 13 squared, 13 times 13, which is 169. Look at the second one. We have addition and we have exponent. Exponent first, 8 squared, which is 64, plus 5 squared, which is 25, to give me 89. Look at the first, look at 8 plus 5 squared and 8 squared plus 5 squared. They have different answers because we can't put the exponent over addition. Okay, the last one, we have addition and exponent. First, let's start with 5 squared, which will be 8 plus 5 squared, 8 plus 25, to give me 33. Okay, here we have, similarly, start with the parentheses, 8 minus 2, which is 6 squared, to give me 36. The second one, 8 squared, which is 64, minus 4, which will be 60. They have also different answers because we can't distribute the exponent over subtraction. The last one, first let's solve the exponent, which will be 8 minus 4, to give me 4. Okay, here we have multiplication, parentheses and exponent. We start with the parentheses, so keep it 2 times, solve the parentheses, 3 times 4, which is 12, keep the exponent squared, so it will be 2 times 12 squared, which will be 2 times 12 squared, 144. The answer will be 288. Okay, the next one, 7 times 25, because we start with the exponent, and the answer will be 175. The last one, start with the parenthesis, 6 minus 6, which is 0. Keep the exponent, 0 squared. 0 squared, 0 times 0, which is 0. Okay, let's start with exercise number 5 because it's very easy. Write in the form of an integer times power of 10. You already took this exercise similarly to it in grade 6. Starting with the first one, integer is 2, 2000 is 2 times 1000, or we can directly write 2 times 10 cubed. The second one, 25 times, we add 3 zeros, so it's 10 cubed. 25 times 10 cubed. The next one, pay attention, we don't write 50 times 10 cubed, it's 5. We put a space here, indicates to the comma, okay, just to separate between periods, which are the unit and the thousand. So it is 5 times 10,000, or we can write it directly, 5 times 10 to the power. How many zeros? 4 zeros. The next one, 3 times 10 to the power 5. You just count the zeros. The last one, 4 times 1 million, or directly we can write 4 times 10 to the power 6. Okay, in exercise number 11, the last exercise, in each of the following cases, find the smallest natural number n. We have to fill in the blank, which is n, so that the given product is an integer. It means I have to get rid of the point. Okay, to get rid of the point, it means I have to multiply by power of 10, so the point will go to the right. How many digits? We have to count the digits. So the first one is 3.75 in the decimal part. In the decimal part, which is 75, I have 2 digits. So I have to multiply 3.75 times 10 to the power 2 to get rid of the point. So it will be 3.75 times 10 to the power 2 to give me 375. Okay, because the point goes 2 digits to the right. The second one, count how many decimal parts we have. How many in the decimal part? How many digits? We have 4 digits, so we have to multiply by 10 to the power 4 to give me 25. Okay, pay attention, they want the answer as an integer, no decimal point. Integer is a number that doesn't have a decimal point. The second one, count the digits of the decimal part. We have 67. The decimal part is to the right of the point, so we have to multiply by 100. 100 means 10 squared. So 25.67 times 10 squared. Move the point 2 digits to the right, so it will go outside to get 2567. The last one, we have 3 digits, so we multiply it by 10 cubed to get 75.408 times 10 cubed to get 75,408. Okay, pay attention. The comma is in its wrong place. We have to put the comma between 5 and 4. Okay, it's a mistake. Thank you for watching, and this is the end of session